Yes, so now we move again to the next concept from this, that is, we'll start with our main binomial expression, that is a plus b raised to n. So what is a plus b raised to n? It is nc0 a raised to n plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2, like this. Now suppose we substitute here a is equals to 1 and b is also equals to 1. So what happened to this? This become 1 plus 1, so that become 1 plus 1 raised to n. This become nc0 1 raised to n, nc1 1 raised to n minus 1 1 raised to 1, nc2 1 raised to n minus 2 1 raised to 2, and so on. So which is nothing but what? It is left hand side become 1 plus 1, so it is 2 raised to n. And the right hand side become what? nc0 plus nc1 plus nc2 plus the last is ncn. And that are nothing but the sum of the binomial coefficients are always equal to 2 raised to n. We can just verify this in the Pascal's triangles also. My Pascal's triangle is 1 1, next is 1 2 1. 1 3 3 1 1 4 6 4 1. So if you observe the sum of the coefficient here, that is 1 plus 1, that is what? 2. So it is nothing but 2 raised to 1. 1 2 1, sum is what? 4, and 4 is nothing but 2 square. This is 2 cube, 8, this is 16, so it is 2 raised to 4. That is, depending on the power of the expression, the sum of the coefficient is always become like this, 2 raised to n. Now the same concept is valid. The same concept is valid for if you take a is equal to 1 and b is equal to minus 1. If you take a is equal to 1 and b is equal to minus 1, this expression become alternate plus minus sign. The same expression become alternate plus minus sign. So it is nc0 minus nc1 plus nc2 minus nc3 and so on. So it is clearly from this, the left hand side becomes 0. So 0 is equal to nc0 minus nc1 plus nc2 minus nc3 and so on. So the even term keep in the right hand side, or you take this side. So nc1 plus nc3 plus nc5, nc0, nc2, nc4, like this. So what is that? 1, 3, 5, 0, 2, 4. The sum of all coefficients, sum of all terms coefficients is always equal to sum of even terms coefficient in this. That is always equals. So that is it. Suppose we assume this is equal to x. Suppose we assume this is equal to x, then we just derive nc0 plus nc1 plus nc2 plus nc3 is equal to what? 2 raised to n. That is nothing but this left hand side and right hand side, which become x plus x. The addition of this two, that is nothing but 2x. So 2x is equal to 2 raised to n. Therefore x is what? 2 raised to n minus 1. That means, so we get a formula here. So what is the formula? nc0 plus nc2 plus nc4, in fact nc1 plus nc2 plus nc3, like that ncn is 2 raised to n. And if you take even power, it will be what? 2 raised to n minus 1, or it is 2 raised to n minus 1, like this. Though in sum of all it is 2 raised to n, only even it is 2 raised to n minus 1, or it is like this. 2 raised to n minus 1. So that is the expression. Now here, instead of this, if you observe this, the n is common in all. The same formula can be written as, because there is the n is common, so there is no need to write n every time in the expression. Instead of that nc0 and c1, we can write the same as capital C0, C1, C2, like this, Cn. So that is nothing but it is understandable. That is equal to what? 2 raised to n. Similarly, so C0 plus C2 plus C4 like this is what? 2 raised to n minus 1. C1, C3, C5. So there is no need to write n every time because it is understandable by the coefficient. But remember, in this, it always starts from 0 and always end to n. What is the starting point there? It's nc0. And what is the end point? It is the nc, and then that become 2 raised to n. So based on this very simple questions which is there in your textbooks, you will solve that few sums. So exercise 4.5. Now a few questions based on exercise 4.4, that is the same concept. So here exercise 4.4, question number 1, show that C0, C1, C2 up to CA is equal to 256. Now this you have to prove. So how to prove this is very simple. Start from the left hand side. LHS C0 plus C1 plus C2 up to C8, and that is given by what? It is equal to 2 raised to 8. The reason is since C0, C1, C2, Cn is 2 raised to n, and therefore it is 256, and that is right hand side. So it is proved. Similarly, next question number 2, C0, C1, C2 up to C9 is equal to 5, 1, 2. This you have to prove. So we can say LHS is equal to C0, C1, C2, C9. Same way, it is 2 raised to 9, so it is 5, 1, 2. That's the right answer. So it's very easy to prove. Understood? But be cautious here. Suppose sometimes they may ask you, or they may test you in this way. The third sum it is given that C1 plus C2 plus C3 to C7, you have to prove that it is 127. That is the question 3. You have to prove that it is 127. So now how to prove this 127? If you look at this, and it is C1, C2, C3, C7. Now, it is not started from C0. Remember that the formula is valid when it starts from C0 to Cn. Here this is not started from this one. So therefore, you have to add and subtract C0. C0 added and C0 subtracted. So this become what? It has become 2 raised to 7, and C0 value is 1. So it is 128 minus 1. So it is 127, and that is right hand side. So it's very easy proof here. So all the rest is almost same. So the one last one, that is question number 7 in this. So we will solve that question. This 4. Exercise 4.5. So last question, question number 5 in this. So question number 5, sorry, question number 7 is this question number 7. C0 plus 2C1, C0 plus 2C1 plus 3C2 like this. N plus 1 Cn. You have to prove that is equals to n plus 2 into 2 raised to n minus 1 into 2 raised to n minus 1. Now this we have to prove. So we start with LHS here. So LHS is equals to left side. So what is the left side here? C0 plus 2C1 3C2 like this and plus 1Cn. Now we will make a 2 bracket now. C0, C1, C2 up to Cn. That is one bracket. And another bracket plus C0 is taken here. So there is no need to write again. But C1, one C1 is taken, 2 C1 is there. So that become C1. Similarly, एक गया C2 तो 2 बचेगा. So it is 2 C2. Like that 3 C3 and last में बचेगा n Cn like this. Now what is the value of this? C0 to C0 plus C1 plus C2 plus C3 up to Cn. The value of that is 2 raised to n. It is what? 2 raised to n. And what is C1? C1 is nothing but NC1. So NC1 is nothing but n. It is n. 2C2 is nothing but 2 into n into n minus 1, 1 into 2. Similarly, 3C3. So it is 3 and n minus 1, n minus 2, 1 into 2 into 3. Like this, the last is NCn. So NCn is equals to what? N into Cn. So n into 1. Like this. Now we observe this, we can take n common routes. N is there everywhere. So it is 2 raised to n. If you take n common here, 1 plus. Now this 2 and this 2 is out and n is out. So what is remain there? It is n minus 1. Similarly, this 3 cancel. N is taken common. So what is remain here? It is n minus 1, n minus 2 upon 1 into 2. Plus, like this, n common. So last में बचेगा वापस 1. And that is nothing but 2 raised to n plus n into, what is this? We can say this C0 plus n minus 1 C0. It is n minus 1 C0, n minus 1 C0, n minus 1 C1, n minus 1 C2. The last name n minus 1 Cn minus 1 like this. So which is nothing but 2 raised to n plus n into 2 raised to whatever power is here, that is 2 raised to n minus 1. Now 2 raised to n minus 1 is nothing but 2 raised to n minus 1 is nothing but we can take 2 raised to n as common in this. So it is 2 raised to n. 2 raised to n split into 2 into 2 raised to n minus 1. This is n into 2 raised to n minus 1. We split 2 raised to n as 2 into 2 raised to n minus 1. And 2 raised to n minus 1 we can take as common as 2 raised to n minus 1 make common. So अंदर क्या बचेगा n plus 2 and that is your right hand side. So like this it is proved. Understood, beta? So it's very simple expression in this. So you have to remember.